Hey guys, today we're going to learn about the derivative. So what we have here on this graph is a quadratic, as we can tell from this parabola. Now on this quadratic, we have several lines here. We have this red line. Now as you can see, this red line goes through the function at 2 points. That's called a secant line. Now this is going to be really strange, but we have this point here, x f of x, and then x plus h, f of x plus h. So what that means is that this is the x, and this is x plus h. That means that the distance between them is the h. So if we look at this first question, what does the expression f of x plus h minus f of x over x plus h minus x represent? Now, if we look at those points, we've used this formula many times before. You just may not recognize it. F of x plus h, that's a y value. And f of x is the other y value. So essentially what this is y2 minus y1 over, then x plus h is an x value, and x here is the other x value. So this would be x2 minus x1. So this is what we know as the slope formula. Particularly because we're talking about these 2 points that are on the secant line, this represents the slope of the secant line. Now for this follow-up question, we have here as h, the distance between the x values approaches 0, what happens to the secant line? So this blue line is just so you can see that I am reducing the value of h, because now the distance between them is much shorter than the distance here. So if we gradually reduce this distance as we take away the h, what happens is that line then becomes what's called a tangent line. A tangent line is a line that goes to the function at exactly just 1 point. So as we reduce the value of h and it approaches 0, the secant line becomes the tangent line. So based on this observation, what do you think the following expression represents? And this is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, this looks like this, except in the denominator we only have h. And that's because we do x plus h minus x, the x's would cancel, and in the denominator we would just have h. But here we're adding on this limit. So the limit as h is approaching 0, that is this, the tangent line. So what this represents is the slope of the tangent line. And as you can see here, the tangent line runs parallel, if not almost parallel, to the secant line. So that's the definition of the derivative, the slope of the tangent line. So we're going to evaluate what this does. Here we're going to find the limit as h approaches 0 of f of x plus h minus f of x all over h for the function x squared plus 2x minus 1. So what I'm going to do is I'm going to take f of x and I'm going to plug it into this expression. But here we have f of x plus h. So that means that for this part of my limit statement, we are going to replace all of the x's with x plus h. So this is what it would look like. The limit as h approaches 0 of x plus h squared plus 2x plus h minus 1 minus all of f of x, which is x squared plus 2x minus 1, and everything, whoops, that came out weird, is over h. Now what we're going to do is we're going to work this out. So in the numerator, we have a lot going on. So we're going to have to expand it and combine like terms. So x plus h squared, that's when you take x plus h times x plus h. Now I'm going to continue working this out and I'll come back to this later. I'm going to distribute this 2. So that will be plus 2x plus 2h. Then the minus 1. And notice here when I had put minus f of x, I put f of x in parentheses since we have to subtract the entire function. So now I'm going to distribute the negative, which would be negative x squared minus 2x plus 1. And everything, once again, is over h. Now let's distribute this. As I distribute, I would get x squared plus xh and then another xh, so that would be 2xh plus h squared. Now here my two x's can cancel because this is a positive 2x, this is a negative 2x. Then I have the 2h, this minus 1 and this plus 1 will cancel. And then I have the negative x squared. And again, everything is over h. We can further combine like terms by this x squared and negative x squared will cancel. And all that's left in the numerator now is the 2xh plus h squared plus 2h, and everything is over h. Now, as you notice, everything in the numerator has an h. So what I want to do is factor out an h. So now what we have is the h on the outside, 2x plus h plus 2 all over h. If you did this process correctly, this will always happen. Now I can cancel out the h, which was the problem, because if I take this limit, I couldn't plug in 0 because I would have 0 in the denominator. So that's the whole point, is that we can cancel out that h, and now I can evaluate for the limit. So this is the limit as h approaches 0 of what I have left, which is the 2x plus h plus 2. If I plug in 0 for h, my answer to this limit is 2x plus 2. This is my answer. This is the derivative. And a derivative is noted as f prime of x. So the prime looks like a little apostrophe almost, but that just means that this is the derivative of the function, which is 2x plus 2. Now in the previous slide, we stated that the derivative is equal to the slope of the tangent line. But if you look at your function, the slope of the tangent line will vary depending on what x value we're looking at. And I'm going to show you an example of that now. So this is the graph of some function, the blue, that's a function. And then this red line here is the tangent line. As you can see, it is going through this point. If I move that point, you see how the tangent line changes. So that's why we end up getting an equation for our derivative, is because this equation we can use to figure out the slope of the tangent line at any particular x value. So if I wanted to find the slope of the tangent line at negative 3, sorry, I would plug it in. So this is f prime of negative 3 would equal to 2 times negative 3 plus 2, which is going to equal to negative 6 plus 2, so negative 4. So if I look here at my point and I draw a line with a slope of negative 4, this is my tangent line. And you see how it goes through exactly one point here. If I want to know the slope of the tangent line at x is equal to negative 1, here's the negative 1, my tangent line will be horizontal. So I can suspect that this is going to equal to 0 because all horizontal lines have a slope of 0. So that would be 2 times negative 1 plus 2, which gives me negative 2 plus 2, so 0. At x is equal to 1, my tangent line is going to look something like this. So I can suspect that my slope is going to be positive since my line is increasing. So f prime of 1 is going to be 2 times 1 plus 2, which equals to 4. So again, that suspicion was correct. So that's what the derivative does, is it helps us evaluate for the slope of the tangent line at any particular x value. So to kind of sum up, what is a derivative? The derivative is an equation that can be evaluated to determine the slope of any tangent line drawn to the graph of f of x at any value of x. So this is the derivative definition. F prime of x is equal to the limit that we evaluated for. Now this limit is called the difference quotient. It's called a difference quotient because we have a difference, the subtraction, and it's a quotient because we have a fraction, which indicates division. And this is what's important. Whenever you see find the derivative, then you must think of that you're finding the slope of the tangent line. Or if you see find the slope of the tangent line, then you have to remember I'm finding the derivative. Those two things are exactly the same. So let's practice that. We're going to find the derivative equation for each of the following functions using the difference quotient. So that means I'm going to apply the limit as h approaches 0 of f of x plus h minus f of x all over h. So f of x plus h, that means I'm plugging in x plus h into every x. So 3 x plus h minus 2 minus f of x, which is 3x minus 2, all over h. We're going to distribute the 3, so 3x plus 3h minus 2, distribute the negative, minus 3x plus 2, all over h. We can cancel out the 3x's as well as the 2's, and I'm left with 3h over h. And then the h's would cancel. So when I evaluated all of this, we end up with 3. So we're finding the limit as h approaches 0 of 3. And the limit of any constant is always that constant. Now keep in mind that the derivative, this is my derivative, so f prime of x is equal to 3. The derivative is equated to be the slope of the tangent line. Now, if you think about this function, the reason why we end up with a constant rather than another equation is because my function here is linear. This is a line. And the slope of this line is 3. So no matter where I go along that line, the slope is always 3. Therefore, the tangent line will have that, the tangent line will be a constant, which is that number, the slope, 3. Let's try that with this one. We have the limit as h approaches 0 of f of x plus h, which would be 4 x plus h squared plus 1 minus f of x, which is the 4x squared plus 1, all over h. Now let's distribute. We got 4 x plus h times x plus h plus 1. Distribute the negative, so minus 4x squared minus 1 all over h. If I distribute the x plus h, just like I did before, we end up with 4 times x squared plus xh and another xh, so 2xh plus h squared. This one and this one will cancel. Minus 4x squared all over h. Now we distribute the 4. So 4x squared plus 8xh plus 4h squared minus 4x squared all over h. Combine like terms, I have a 4x squared and a negative 4x squared. And now all that's left in the numerator is 8xh plus 4h squared. I can factor out an h to cancel out the h in the denominator, and that would give me 8x plus 4h all over h. My h's cancel. This is my simplified function, so now I'm looking for the limit as h approaches 0 of 8x plus 4h. If I plug in h is 0, that would give me 8x plus 4 times 0, which is 8x. So my derivative, f prime of x, is going to equal to 8x. Now, a pattern that you should notice is that my function here is a quadratic, meaning my highest exponent is 2. We call that the degree. The degree of this function is 2. The degree of my derivative is 1 because even though we don't see the exponent, it's 1. So the derivative should always be 1 degree less than the original function. If I look here, this is linear. The degree is 1. So the derivative should be 1 degree less, which is 0, meaning there would be no x. So that's a pattern that we will notice as we continue on with this lesson. Now we're going to take it a step further. We figured out how to find the derivative, which is the equation to get the slope of the tangent line. But one of the most common questions in calculus is to find the equation of the tangent line. So we want the equation of the line. Now, we know equations of lines as either y equals mx plus b, or the point slope form, which is y minus y1, which is equal to m times x minus x1. We don't really use y equals mx plus b because to solve for the y-intercept, we would need to first get it in the point slope form. So what we're going to do is write our equations in point slope form only. Now, how do we get it in point slope form? I have my function and I have the given x value. I have steps here that we can follow in order to figure out that equation. The first thing we're going to do is we're going to find f of x at the indicated value of x. That is going to give me my point of tangency, which is the x1, y1. It's called a point of tangency because that is the point that the tangent line touches the function. I have the x value that's given. What I need is the y value. So I take that x, I plug it into the equation to get the y. So f of 2 is going to equal to negative 3 times 2 squared plus 4. 2 squared is 4 times negative 3 is negative 12 plus 4. And negative 12 plus 4 is negative 8. So my point of tangency, and that's what I'm going to need to use later for the equation of my tangent line, is 2, negative 8. So I'm going to hold on to this information for later. The next thing that we need, because now I have x1 and y1, is I need my slope, which that's the derivative. So now I'm going to do the limit as h approaches 0 of my difference quotient. So the f of x plus h minus f of x all over h. So negative 3 x plus h squared plus 4 minus f of x, which is the negative 3x squared plus 4 all over h. Let's start distributing everything in the numerator. So I got the negative 3 x plus h times x plus h plus 4. Distribute this negative, so plus 3x squared minus 4 all over h. We can distribute these binomials here just like we've done before. So negative 3 x squared plus xh and another xh, so 2xh plus h squared. The 4's here will cancel because one is positive and one is negative, plus 3x squared all over h. Now we distribute the negative 3, and we would get negative 3x squared minus 6xh minus 3h squared plus 3x squared. These will cancel. Everything is over h. And now I can factor out an h from the numerator. So we got h, negative 6x minus 3h over h. Now these h's cancel. Now I can evaluate for my limit. So the limit as h approaches 0 of negative 6x minus 3h is equal to negative 6x minus 3 times 0, which would give me negative 6x. So this is my derivative. F prime of x is equal to negative 6x. What I need is the slope of my tangent line. Remember that this is going to let me find that slope at x is equal to 2. So I'm going to plug that in now. F prime of 2 is going to equal to negative 6 times 2, which equals to negative 12. This is my slope. So now that I have the slope and I have the point, I can put it in point slope form. So the equation of my tangent line would be y minus y1, which is negative 8. So y minus negative 8 becomes plus 8, is equal to my slope, which is negative 12, times x minus the x value, which is 2. And that's it. You can leave your answer like that. If you wanted to, you could write it as y equals mx plus b by distributing the negative 12 and then subtracting the 8. But you don't need to do that extra work. We can leave it just like that. So, in conclusion, just to make sure that we understand, when we find this limit, what that gives me is the equation for the derivative that can be used to plug in x to find the slope of the tangent line at any given value of x. Let's try this process one last time. Okay, so what we're going to do now is we have this function f of x is equal to 3x squared plus 3x plus 3, and we want to find the equation of the tangent line using the difference quotient at the value of x is equal to negative 1. So remember, the first thing we're going to need is our point of tangency. We got the x, we need the y. So we're going to plug in negative 1 for x. And that would give me 3 times negative 1 squared plus 3 times negative 1 plus 3. Negative 1 squared is positive 1, times 3 is 3. 3 times negative 1 is negative 3, plus 3. 3 minus 3 is 0, plus 3, we get 3. So my point of tangency is going to equal to negative 1, 3. I'm going to hold on to this information for later. Now we need to find the derivative, which we're going to get the limit of the difference quotient, which remember is f of x plus h. So I'm going to plug in x plus h for every x. So that's 3 x plus h squared plus 3 times x plus h plus 3 minus all of f of x, so 3x squared plus 3x plus 3, and everything is over h. So let's work on cleaning up this numerator. So that's 3x plus h times x plus h plus, distribute the 3, which is 3x plus 3h plus 3. And now I can distribute the negative, which would be minus 3x squared minus 3x minus 3, and everything is over h. I can cancel out a couple things here already. I can cancel out the 3x's, and I can cancel out the 3's. Now let's work on distributing here. When I distribute this binomial, as we've seen many times already, that's x squared plus 2xh plus h squared. Then I have the plus 3h and the minus 3x squared, all over h. Distribute the 3. We get 3x squared plus 6xh plus 3h squared plus 3h minus 3x squared all over h. Now I can cancel the 3x squared. And the only thing left in the numerator all have h's, so I can factor out the h, which would give me 6x plus 3h plus 3 all over h. My h's cancel. So this is my simplified function. So that's going to lead me to the limit. The limit as h approaches 0 of 6x plus 3h plus 3. When I plug in h is 0, this would cancel, so I would get 6x plus 3. This is my derivative. So now I want to know the slope of my tangent line when x is -1. So I'm going to plug in -1. And that would give me 6 times -1 plus 3. This is -6, and -6 plus 3 is -3. So I have my slope, I have my point. I'm going to put it in my point-slope form. When I plug this in, I would get y minus the y value, which is 3, is equal to m, which is -3, times x minus the x value, which is -1. So x minus -1 becomes +1. And that is the slope of, the equation of my tangent line. And that's your intro to derivatives.